Now here's another example. I want to use linear approximation to estimate sine of 3/4. Now very common, like in homework problems that you'll be dealing with, it'll say at a known point, like x equals pi over 4. And that's what I'm going to use here. I'm going to use pi over 4 because, you know, pi is 3.14, yada, yada, yada. So pi over 4 is roughly 3 over 4. So pi over 4 should be pretty close to 3 over 4. So sine of pi over 4 should be close to 3 over 4. So what I'm going to do is, first I'm going to find is that point. So I'm going to consider f of x to be sine of x. And I know that f of pi over 4 equals sine of pi over 4. Sine of pi over 4, like I said, is going to be close to sine of 3/4. Well, sine of pi over 4 is root 2 over 2. That's a common angle. That's one reason why I picked it. I mean, when you pick these values, you have to pick a value that you know. It's not like you go grab a calculator and approximate it. If you could do that, then just approximate this to begin with. So I have sine of pi over 4 is root 2 over 2. So now I now have a point. My x-coordinate is pi over 4. My y-coordinate is root 2 over 2. So now I need to find the slope. F prime of x, the first derivative, will be equal to cosine of x. I need to evaluate that's at x equals pi over 4. And cosine of pi over 4 happens to also be root 2 over 2. Pi over 4 is where sine and cosine are equal to each other. So this is now my slope. So what I'm going to have is y. Now, you know, I'm going to change notation just slightly because I want you thinking about this. I'm going to jump right to the linearization notation. So the linearization of x is equal to, in this case, it's going to be f of pi over 4 plus f prime of pi over 4 times x minus pi over 4. Now, to tie this in what I did earlier, a is pi over 4. So all this is f of a plus f prime of a x minus a. That's all that is. So this is going to be f of pi over 4, which is root 2 over 2, plus f prime is again root 2 over 2 times x minus root 2, not root 2, it's pi over 4. So this is my linearization of x. I'm sorry, linearization of sine x near, and this is extremely important, near pi over 4. Now I need to approximate sine of 3/4. So sine of 3/4 equals the linearization at 3/4, which would be root 2 over 2 plus, and actually I should make this approximately, root 2 over 2 times x, which is 3/4, minus pi over 4. So when I go ahead and actually work that out, what I get is approximately 0.6821. Now, if I take a calculator and I find sine of 3/4, what I get is approximately 0.6816. Now, it's really important here to note that I'm working in radians. Okay, don't be messing around with degrees. Get your calculator in radians if you're going to confirm that. So really, in a nutshell, that's really all there is to linearization. It's just a matter of finding the equation of the tangent line and using the actual equation of the tangent line to approximate values of the function near the known point. And the known point is the point where the tangent line touches the function.